Hello and welcome guys. So in the last video we discussed about spectrogram in detail and also about Python Librosa library, how easily we can load any audio file and pre-process and extract the feature from that audio file using Librosa. These things we have discussed in detail. Okay, so in this video we will start our project. So first let me activate my environment. So here I am activating my TensorFlow environment. TensorFlow. So some of them are asking question in comment. I don't have this environment. So this environment I have created. Okay. So if you want to create this environment, then you have to write this command. First you have to install Anaconda, and then you have to write this command conda create minus name, and then you have to give the name of that environment. Then here if I am giving some ABCD, some environment name, and then you have to give the Python version, which Python version you want. So like Python 3.10 you want. So if you hit write this command and hit enter, then you will get this environment. Okay, to activate this environment you have to write conda activate ABC, then you will be able to activate your environment. Okay, so here I have activated my TensorFlow environment, if you see here. Okay, now to see what are the packages I have installed in the environment. So if you're doing it for first time, then you have to install all the necessary package like TensorFlow, Librosa. You have to install inside this environment. Okay, so let me show you what packages I have. So to see the packages in Anaconda environment, you have to write conda list. Okay, so if you see, these are the packages inside my TensorFlow environment. I have this Flask also installed here, and matplotlib is here. So these are the packages, and LTK is there. And if let's see what is needed for our project, like TensorFlow. So TensorFlow is also here. Okay, I am using TensorFlow GPU. So these are the dependencies of this TensorFlow. TensorFlow 2.15 I am using here. Streamlit also installed in this environment. And if you see, Librosa is also here. You will get Librosa. Yeah, here Librosa is also installed. Okay, so these are the packages which is installed inside my environment. So you have to install all these packages by doing pip install. Okay, if you are facing any difficulty, then please post in the comment box. My environment is ready and all the dependencies are here. Now let's open Jupyter Notebook. So to open Jupyter Notebook, you have to write here Jupyter Notebook. Just then, inside my TensorFlow environment, I am opening my Jupyter Notebook. So this is my desktop, and inside my desktop I have to go in this. I have created this folder for you, and inside this, if you see, this is genres original. This is the, if I go inside, then I will get all the 10 genres here, and inside this I have wave file. Okay, so these are my classes, and so this is my data set. Okay, now as I already showed you, you can download this data set from here. This is our data set. So if you download this data set, then you will get two directories like this: image original and genre original. We have already discussed in detail about these things in part 1 of this video. So we are not going to use this image file, which is spectrogram. We are going to use this raw audio file, and we will make a spectrogram from it. We will extract the feature from it and train our model. Okay, so that's why I have only taken here in my current working directory, I have only taken the audio file, not that image and all. Okay, now let's create one notebook here. So I am creating one notebook. So here I have to select the kernel. So as I already created a TensorFlow environment, so I will select my Python 3.10 from TensorFlow environment, and I will click here. So my Python 3.10 in TensorFlow environment is ready. Okay, now I will give a name to this as a train music genre classifier. This is the name of my notebook. Now first we have to import some necessary libraries. What libraries I need? First one is import OS, and second one I am importing Librosa, and third one I am importing matplotlib, matplotlib.pyplot, as PLT, and fourth one, which is most important one, is TensorFlow as TF. So this thing I need right now, and whatever needed later we will import that. Okay, so first what we will do, we will load some random file from it, and we will see what is the, we will visualize it and understand that how this audio looks like. Okay, so what I am doing, I am copying this thing from here, copy this, and I am pasting here. Okay, I'm pasting this file here, and okay, and let's take one more. Okay, we will take later. So this thing I have taken from here. So this, what I have done, I have taken a random file from any of this class. I am selecting blues. So I have taken one random file from it. Now let's visualize this audio file first. So I'm commenting here. Let's give a markdown. Let's give the one variable random file name, and let's give a path of this. So I'm copying the path from here, copy path. I'm going here and I'm pasting it here. No need to write this desktop. No need to write this. We'll give a dot slash. It means whatever present in current working directory, take it. So this is the meaning of this. Now what we will do a visualization of this, as we discussed in detail in the last video, that how we can load using Librosa library. So I'm giving here y and sampling rate, y comma sampling rate, and I'm writing here Librosa dot load. Okay, and here I have to give the path. So I'm giving the path as a random file name. So this is my path, and sampling rate I have to give. Sampling rate I am giving 44100. Okay, this sampling rate I am giving. If you are worried that how I am loading this thing, then you can go to this documentation Librosa. If I go inside this core IO, if I go inside this audio loading, if you go, you will see these things, and here is the function for this. And if I go to the example, then you will see here that to load any file, this thing I am using here, I am giving the file name, and sampling rate we can pass anything, like here it's passing 11,025, and there I am passing this. Okay, you can also use default sampling rate by using only this thing. Don't use this, then Librosa.load, whatever is the default sampling rate for Librosa, you will be able to use that. Okay, and if I show you that what is my y and what is my sampling rate, then you will see this thing. This is my y, which is array, and this is my sampling rate, whatever we have passed here. Okay, the same thing we will get. Okay, if I do a y dot shape, and you will see that this much is the array length. Okay, almost 1.3 million elements are there in this array. Okay, now let's visualize this. So let's remove this thing, we don't need this. So to visualize this, I am writing here plt.figure, and inside this I am passing fixed size. I am giving some fixed size here. Fixed size I am giving here 14,5 I am giving. Okay, this is about fixed size, and then give here librosa.display.waveshow, and inside this we have to pass first parameter as y, and second parameter will be our sampling rate, which is SR. Okay, if we do the visualization of this, then you will get this thing. And again, this librosa.display.waveshow I have taken from the documentation. Okay, so this is the visualization of this entire audio. As we have already seen in the data set that this audio length is of 30 seconds. So here if you see, this is a time, x-axis is time, and y-axis is the amplitude of this audio signal. So here 0 to 30 is the time and this amplitude, and this is the visualization of this audio signal, which is this blues this dot wave. Okay, this first file of blues class. Also, if you want to see that how exactly what is inside this file, then you can also play this sound. So to play sound using Python, we also have some library. So you have to write here from ipython.display. This ipython you have to install using pip install ipython. Okay. From ipython.display, you have to import audio. Okay. And inside this audio, you have to pass two things. First one is data, which is your y, which is that array. Okay. And second one is rate, which is your sampling rate. If you run this, then you will get this thing. And you can play by doing this. So that's how you can play this audio. Now let's take some other audio and let's see the visualization of this. Okay. So I am taking second another audio from Zaz. Let's take this audio. First I have to copy it from here, copy, and then I'm going inside my here and let's paste here. Now what I will do, I will copy the path from here. I will go here and I will replace it with that. No need of this thing. So this is my Zaz01.wave. I'm running this cell. So you see here, this is another visualization of this thing. So this is something different. Okay. If I run this, then you will be able to play this audio also. Okay. So this is a visualization of Zaz and previous one is a visualization of blues. Okay. If I do the visualization of it again, here is a visualization of Zaz, and if I replace it with this blues, copy path, I want to show something to you. Okay, so this is a visualization of blues and this is a visualization of Zaz. Size is 0 to 30 second and here also size is same, 0 to 30 second. If we build melispectogram directly using this audio file and feed to our model, then it's very difficult for our model to extract the feature and understand the pattern in this audio signal. Okay, it's very hard because if you see this zigzag and this audio file, then model is unable to understand exactly what is the pattern in blues audio. Similarly, for this Zaz audio, model is not able to capture the trend from this graph. Okay, and if we build melispectogram on the top of that, then also it's very hard for the model to interpret it and understand that what is the pattern and what is the insight, like what is the important feature in it, how it is different from blues, how rock music is different from jazz, blues, how classical music is different from other musics. It's very hard for model to understand. Okay, by if we feed directly this audio and build a melispectogram, then it's very hard for model to understand. If you take this audio file and build a melispectogram and feed to the neural network, then definitely you will get accuracy 50 to 60%. You will not get good result. Okay, that's why it's not a good approach that we can directly take this array and build melispectogram and feed to the neural network. Okay, so we have to do something. Okay, so in the next video, what we will do, in next video we will do a visualization on chunks of audio, and then I will show you the difference between this audio file, whatever we got here when we plot this thing, and also we'll plot the chunks of that audio file, and then we will see that the difference between the visualization, and we will understand that okay, so this thing, if we feed to the neural network, then definitely we will get a good result. Okay, so that thing we will discuss in the next video. Okay, so that's all for this video. We will meet in next video. Thank you guys. Thanks a lot for watching this video.